Hey y'all, I'm going to show you 3 different ways in how to sketch or graph a parabola. So the first way is called the formula method, and it's going to be the more like detail-oriented method, and then it progressively gets easier as we go down the list of methods. So I'm going to do the more like complex one first. So here's the thing, we're dealing with parabolas, and a parabola looks like this. Here's the coordinates plane, that little graph. Right? This is what they look like. And then we have the parabola that looks like this. And then we have another version that looks like this. And they can look different, but these are the ones you kind of see a lot. The one that looks like right side up and upside down. So we know we're dealing with parabolas because of this little 2. When you see that little 2 dangling, you know we're going to have basically this really deep curve that looks like a letter U. That's what we're messing with. So what we're going to find is the endpoints and the vertex, the end points and the vertex. That's what we're looking for. We're going to basically get formulas for both of these things. So the endpoints are these little guys right here. The 2 lines that kind of line up, the endpoints, and then the vertex is that very, very tip. That's the vertex. So I'm basically going to give you formulas for these 3 things. You're going to put those dots down and you're going to trace the dots. That's essentially what we're doing here. Okay, so how do we start? Well, step 1, right now we're looking for the endpoints. So this part I'm going to show you is for the endpoints, and then we're going to go into the vertex. So we're going to start by making y equals 0, and then we're going to FOIL, first, outer, inner, last. So we get x's here, and then I'm going to do a 4 here and a 1 here. So we can get the middle and then the last, right? So we FOILed. The next step is I'm going to make all my terms equal 0. So everything in the parentheses equals 0. So x plus 1 equals 0, and then x plus 4 equals 0. Great. So what I did was I made y equals 0, and then I FOILed, and then everything I came up with in FOIL, I made that equal 0. Now I'm going to isolate all my x's. X equals -1, and then x equals -4. All I did is throw it over on the other side and switch the sign. That's it. That's what isolating the variable means, or isolating the x. Cool. So, I mean, I'm pretty much halfway there. I found 2 points, right? So this is for like the -1 would go here for x, and the -4 would basically go like here. So what about y? How do I find y? Well, we already decided that y is 0. So my endpoints are going to be -1 and 0, right? And -4 and 0, because I decided that x's are -1 and -4, and I also decided that my y is 0. So these are the endpoints, So here's what's up. If you're going to FOIL and it's just not working, you know you're doing the math every which way and it's just not giving you what you need, it might mean that you need to use a different method. So if FOIL, and this is for anything, by the way, if you have to kind of factor stuff out and FOIL stuff out and it's just not working, the very next thing you should do is use the quadratic formula. This is that quadratic formula thing. It's -b plus or minus square root of b squared minus 4ac over 2a. And then you just plug everything in, and you're going to end up with 2 answers, right? Because you got this plus and minus sign. So you got to do the whole guy twice. You have to do the whole game twice. So you're going to get 2 answers. And that's going to be your x. Those are going to be your x number 1 and x number 2. And then your 0 was y, remember? So that's how you can figure it out if the FOIL method doesn't work. I have a video to show you how to memorize this quadratic formula in like 30 seconds. So it's kind of like a mnemonic thing. Cool, so we figured out the endpoint. Let's go ahead and do the vertex now. The vertex, we're going to find the x and y. We only need 1 because there's only one single point, right? So we only need 1 x and 1 y. So to do that is x equals -b over 2a, and then the y equals c minus b squared over 4a. That's literally the formula. So how do I know what's A, B, and C? Well, this is A, this is B, this is C. The same thing with the quadratic A, B, and C. You're using the same exact letterings for numbers and numbers for lettering. And what we're essentially doing is using, for all of these, for A, B, and C, we're using the coefficient. This is an invisible 1, this is a 5, and this is a 4. So these are coefficients, A and B. Any kind of number that's in front of the letter is called a coefficient. If it's just a number naked by itself, like C is, that's called a constant. So A and B are coefficients, C is a constant, and this invisible 1 is called the leading coefficient. So that's kind of the setup of this. So I'm looking at my coefficients for negative B, which is 5, negative 5 would be, right? And then 2, and then 1 for A. And again, these are all coefficients. What does that give me for x? It gives me negative 5 over 2, or it gives me negative 2.5. It helps to break it down into decimals. Okay, cool. So now I have the same thing over here. C is 4 minus 5 squared over 4, 1. This thing all has to be in parentheses. If you put it into your calculator, make sure you put this giant parentheses around it. Okay, and that's going to give me negative 9 over 4, or it's going to give me negative 2.25. So my vertex is 2.5 comma negative 2.25, right? That's my vertex. Vertex. Cool, we got all our points. I need 3 points. Here's the first set, here's the second set, here is the third set. So let's go ahead and draw this out. 1, 2, 3, 4. Let's do 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So these are negative, and these are negative. This is positive, and this entire row is x. This entire row that's going up, or even going down, is y. And this is x. Cool. And we know what's negative and positive. So now we can set everything up. Let's do the points first. I have negative 1 and 0. Negative 1, 0 is right here. And then I have negative 4 and 0, which is right here. Those are my endpoints. Okay, so now I need to put the vertex in. It's a little bit tricky because it's not a whole number. It has like these little decimals in it. So let's go ahead and try to do it. I have negative numbers, so I'm going to stay in quadrant 3, which is right here, quadrant 3. And I'm going to do 2.5, which is 1, 2.5. With the vertex, I like to make a really skinny little dotted line so I can figure out where it goes. And then I like to erase it if I'm using a pencil. So that's x. And then y is negative 2.25. Negative 2.25. 1, 2. Let's go here. Perfect. So it goes right here. Those are my three dots. Now I can go ahead and connect them. There we go. That's how you do it. It's supposed to be more curved. I'm just having a hard time drawing it out. But this is literally the answer right here. This graph, this picture is the answer. These dots, these little dotted guys that we came up with, those are also the answer, but we're looking for a graph, so this is the answer. So that's the formula method. It's just basically FOIL and then these two formulas. That's all it is. It's FOIL and these two formulas. Let's use a different method. This is called the parent function method. So the parent function method is, so the parent function of a parabola is literally like this. This is what it looks like. It's just down in the center. This is called point of origin. Point of origin is just when it's on that little tiny cross where it's 0, 0. Point of origin is literally 0, 0, right dead center. Everything starts there, right? So that's where the vertex is located. That's the parent function, which means this is what it originally looks like, and all this stuff that we're adding on, like right here, makes it basically an offspring, so it changes up. So anytime you see anything in parentheses, which we don't have anything in parentheses, but if you see something in parentheses up front with like X and Y and stuff written in it, it is going to go left and right in terms of movement, and any constant you see, just a naked number by itself, it goes up and down. What does that mean? Well, we're just going to draw it out. We're just going to draw it out. So the original, this is the original, this is the OG function, right? The parent function. So we're basically going to copy this, but shift it over. So it looks like we don't have anything for the left and right. So what we're going to, or the parentheses, we're going to go up and down. I have a positive 1, so I'm just going to go up y. We're just going to go up 1. You're going to put a dot there, and you're going to move it up 1. And that's it. That's all you do. You just align all the numbers, and you just move it up 1. And maybe that doesn't make a lot of sense, but let's try this one. Let's try this one where it's really elaborate. So the same concept here. I have parentheses, so I'm going to go left and right on my scale or my graph. And with this constant, the naked number by itself, I'm going to go up and down. This is going to be shrink or stretch. This is that coefficient we were talking about earlier. Coefficients, it's a little bit an estimation, right? So let's try this. Okay, so the parent function, right, was, and you can Google this parent functions. You'll get a list of all of them. Like you'll get like the cube root, the linear, square root, and they show you what they originally look like. And all this kind of elaborate stuff with all this extra stuff added onto it, those are like their offsprings. So they just look more like complex, and they're kind of stretched out, or like they're really like short or moved over all over the graph. That's basically it. Because the original was x2. Like this original one is called y equals x2. Which is right here. Here's my little x, here's my little 2. That's the OG guy. Here's my original. So now we're going to draw this version. Well, let's go back a little bit. I'm going to show you the original right here. This is the original. I haven't even touched the formula it gave me yet. This is my original, the OG, which is the parent function. The second thing we're going to do is we're going to look at this x plus 9. I'm just looking at the numbers only. We're not even worried about that little 2. It says it's moving left and right by 9. If it's in a parentheses, you do the opposite. If it's just hanging out by itself naked, no letters, you do exactly what it says. So it says 9 positive, so I'm doing opposite 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here, negative 9. That's what it looks like. That's all I'm doing. I moved it over 9. That's step 2. That's negative 9 to the left. Because I just had to do the opposite of the sign. So here's the next thing. It wants me to go up 1. We're not doing the opposite because of the second part. When it's not in parentheses and there's no letters, it's a constant. We do exactly what it says. We go up 1. That's 1, 2, 3. So we're just going up 1, which is right here. We were originally over here, right? We were originally here. Now we're going up 1. So that's the final answer right here. This is a shrink and stretch. This one is a 6 is a stretch. I'm going to make another video for that. So just know that it's going to be like kind of thin. It's going to look a little bit thin. So that's what this looks like. All we did is we went, this is what it looks like. Negative 9, positive 1. We went down 9 and we went up 1. That's all we did. Right here. Do the opposite. We went down. Wait, I guess we went left 9 and we went up 1. That's it. That's all we did. And that's how you draw that one. This one's a little bit more abstract if you're doing a quick sketch. This one is called the plug and chug method. This one is, I think, the easiest. I think this one requires like the least amount of energy, basically, because you're just throwing everything in very quickly together. you literally just put in random numbers into X, and then you hit enter on your calculator. If you're not using a calculator, just do it by hand. And whatever comes out as the answer is going to be Y. So let's go ahead and set it up real quick. I'm thinking I'm going to make a graph right here. And you just pick any random numbers. Make sure you include a 0 because, we want to do it as close to the point of origin as possible. So this is the easiest method. The only downside is like your graph could be way off. Like it could be like a -15, -30, and you're over here doing like -1, -2, -3. So it can take a minute. Hopefully that's not going to be the case. So we're going to pick random stuff for X because we're going to throw that into the calculator and then whatever we get will equal Y. So we're going to have to wait for Y for a second. So we're just picking out the X's. So let's do -1 and let's do -2 for now. And then 2, let's do 1 and then 2. So let's go ahead and set it up. So we don't know what Y is yet. So let's go ahead and do 0 first. All I'm doing is just replacing all the letters with the number I assigned. Oops. Let's do this. Okay. So I'm going to erase that. I don't want to. Okay. So I have 0, 0. This makes 4. So what does that mean? I got a 4 right here as my answer. Because I picked 0 and then I ended up with 4 as my answer. Let's do -1 next. So when you put this into your calculator, make sure you put your negatives into parentheses when you're doing a square right here, this little 2, because otherwise you could end up with the wrong answer. So just test out your calculator to see what's up. Okay, so I have all this and it makes 3. Perfect. So -1 gives me 3. Let's do -2 next. -2 in the parentheses. Then I have 2, -2 plus 4, which would give me 4. Which let's put that here, 4. And then let's do the +1 next. Square plus 2, 1, 4, 6, 7. 7 right here. And then let's do the last guy, which is a 2. Square plus 2, 2 plus 4, 8, 12. 12. Cool. So these are all my Y's, and everything I plugged into the letter are my X. And that's reflective right here in my bookkeeping. Let's go ahead and plot this. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, and 8. I mean, there's this right here, which is 12, but I'm running out of room, so let's leave that out for a second. So I have -2 and 4, which is 1, 2, and then 4 is right up here. So then I have -1 and 3 next. -1 and +3 right here. And then I have 0 and +4. 1, 2, 3, 4. Great. And then I have +1 and 7. 4, 5, 6, 7. Great. There we go. So it looks like, and we could do 2 and then 12. We can go all the way up here if we had that. So you're kind of seeing, if we graph it, trying to do a little sketch of it, you're seeing that it ends up right there. Great. So this is a different way of doing it. So the first method was the formula method. The second method was the design method, where you kind of see where it goes by observing the actual formula itself. Every single part of the formula has a determined way of how to do it. Shrink or stretch, going left or right, going up and down. Because something is dedicated to X and Y, something is dedicated to the size, expanding, contracting of the shape. And then it's based off your parent function. And then the third method, I personally think it's a really easy method. It's just pick random numbers and just throw them into X, and then whatever comes out is going to be your Y. This method number 3, is the easiest to remember in a pinch, like if you're like taking a test or something. But the most sufficient way, like the most quickest organized way, would be method 1. I personally think method 2 is the easiest for me personally, but you have to have a little bit of foundational knowledge because there's ways of like learning how to do the movements and how to do it very quickly and visualize it very quickly. If you've never seen that method, it's number 2 is going to look crazy, like it's not even going to make sense. So, okay, I hope these 3 methods helped. And let's see, I do have a sticker shop if you guys want to check it out. It's in the link if you want to. No pressure. Okay, cool. Thanks, guys. Bye.